All right, here is the 7-segment digit clock, version 3.2C. This design is based on the version 3.0 mechanical counter. In total, there are 99 3D printed components, along with 7 rubber bands, 3 micro limit switches, 3 12-volt stepper motors with drivers, a real-time clock module, 9-volt power supply, an Arduino Uno, and then finally M3 and M2 nuts and bolts. Since version 3.0, counter shown here, a few general components have been updated, labeled v3.2. However, some components did not change. Laid out right here are the components that did not change. All 7 segments will remain the same from version 3.0, as well as the required rubber bands on the seg plate, the countersunk screw, the 2 timing gears, and the set of 6 cams for displaying a 0 through 9. The seg plate has received an update, now labeling it as v3.2. However, this is backwards compatible with the v3.0's body. The difference being the seg plate has lost the outer boundaries of the 4 circles that used to fit around the screw shafts within the body. And the reason for the new seg plate having the open corners is to fit around these new bridges that I've added here between the screw shafts and the walls of the body. The reason for this bridge is to improve the strength of these screw towers in an effort to prevent them from breaking off. And then with this clock version 3.2C, here are all the components that are new and specific to the clock. Quickly, a new mid plate, a new back plate for a single digit, back plate for the hours digit, a new mini seg plate for the hours tens place, a driven gear, a drive gear that attaches to the stepper motor, a limit switch spring, a new D2 cam, a new D1 cam, a hours tens place cam, the hours tens place segment, a new style screw for holding the 2 halves of the clock body together, a new screw with a standoff for both supporting or attaching the back plate as well as supporting the case back plate. And then 1 new rubber band required for this single hours tens place segment. And last but not least is the body itself. This is a 2-piece body with matching 2-piece case backplates. There are 2 halves for the purpose of fitting on a print bed that has a XY of no greater than 250 millimeters. Specifically for the parts shown in this video, I'm using the Bambu Lab X1C and P1S. To join the 2 halves together, they slide together using a tongue and groove or track system, both here on the outside, as well as these circles, all need to fit together. So they simply slide together. They're secured together using a recessed countersunk screw that also acts as the colon. Just a note, these screws do have the same thread pitch and length as the standard screw used throughout this assembly. The screws have a flat blade cutout here at the opposite end of where you would expect it, and the purpose of that is so that a flat blade cutout is not seen at the face of the clock for aesthetic purposes. So to install this, simply drop the first one in. I'll be using a 3.5 millimeter flat blade screwdriver, and from the back side, reach in there, insert the screwdriver into that flat blade cutout, and rotate in the counterclockwise position. And do the same thing for the other one. For this 12-hour clock, there are 2 types of cam sets. The first will be used for displaying a 0 through 9, shown here in the top 2 rows, and the second set will be for displaying a 0 through 5, shown here in the bottom two rows. In total, there will be two sets of the 0 through 9 required, one for the minutes ones place and a second for the hours ones place. Only a single set of the 0 through 5 cam assembly will be required, and that's used in the minutes tens place. Additionally, identifying the two sets can be achieved by using the DeBoss text. The 0 through 5 set will have a -6, and the 0 through 9 set will not, and only have the two identifying characters. On the identifying characters, all of the cam sets will use either A, B, or C, followed by either a 1 or a 2. The A, B, or C represents which of the segments this particular cam controls, and the 1 or 2 represents which of the stacks it falls on, either a D1 or D2. The fourth cam type will be the D cams. All of the C, B, and A cams will stack on top of the D cams. A D1, which is identical for both the 0 through 9 and the 0 through 5 sets, and then a D2, which is unique to each of the sets. Before stacking these, while they're easy access to the cam profiles, I will apply a small bit of synthetic lubrication to a point along each of the cam profiles. And lastly, time to assemble the stacks. Starting with the D cam, in this case D1, it'll be followed by a C1, a B1, and then an A1. Likewise, starting with D2, it'll be followed with a C2, a B2, and an A2. The same sequence applies to the 0 through 5. And since two sets of the 0 through 9 will be required for the full assembly, here is the other 0 through 9 set. All right, moving on to the seg plate and D segment. In total, there are 3 identical seg plates and D segments. So starting with the installation of the D segment, this one will snap into place into this center track here with the smooth side facing up and the circle down at the bottom, holding the D segment in this orientation with the cutout down towards that circle. Slide this into place and then give it a diagonal push down and towards the top of the seg plate to snap it into place. Make sure this free falls so that it doesn't create any binding down the road. The rubber band will install around the base of these two center posts into those detents, making sure that the top side of the D segment extrusion sits under the outside loop of the rubber band. All right, installing the cam stacks. I'll start with a seg plate that will be used for a 0 through 9 display. I'll first add some lubrication to the profile of the D2 cam, holding the seg plate in the upright position and pulling the D segment out of the way. I'll drop the D2 cam assembly onto the lower pivot point. Using a flat blade screwdriver, I'll rotate this a few times, making sure there's no binding with the D segment or D cam. And then finally, adding the D1 stack at the upper pivot point. All right, installing the remaining segments. The perimeter segments consist of 3 types, labeled with either an A, a B, or a C. Matching the letters on each segment with the DeBoss letters on the seg plate. Install each segment as shown. Next, the rubber band. Install that around the outer posts, and then pulling it inside the center posts. Second, make sure that the cutouts or hooks on each of the segment receives the rubber band, and then that the rubber band falls into the detents of all 6 seg plate posts. I'll add a small bit of lubrication to behind each of the segments on the seg plate. I'll now install these seg plate assemblies into the body, making sure the 0 through 5 assembly installs into the center digit. Lastly, I'll test each rotation of the cam stacks to make sure there's no significant binding, using the flat blade cutout on top of each of the D camshafts. Moving on to the timing gears. Each digit will get a set of 2 timing gears labeled with either a number 1 or a number 2. The difference between these is the location of the timing indicator. The number 1 points to a valley, the number 2 points to a peak. I'll install the number 1 timing gear on the D1 camshaft and the number 2 timing gear on the D2 camshaft. First, I will rotate the D camshafts to the home position, which is when the arrows at the top point towards each other. So first installing the number 1 timing gear, and then the number 2 timing gear, lining up the 2 timing indicators. Moving on to the mid plate. There's a total of 3 identical mid plates that will support the drivetrain components. To install, simply drop into place on top of each of the seg plate assemblies, making sure it falls and is seated completely. There's a total of 3 identical driven gears. One note, this key located on the center shaft is only used in the hours digit. Second, there's a cylindrical boss around the perimeter of the gear that is used for engaging a spring that pushes the homing limit switch. To install the driven gear, simply drop onto the D1 camshaft. There's a total of 3 identical limit switch springs, 1 for each of the digits. Orient the spring with the extension side up, drop the 2 slots over the 2 small cylinders, and making sure the track is lined up with the push rod, demonstrating how the driven gear engages the spring. To be safe, I'll add a small drop of lubrication between the contact points of each the spring and the driven gears. All right, focusing now on the hours digit, I'll introduce the hours carry cam. There is only one of these. It'll only be used in the hours digit to engage the hours tens place digit over here in this section. So this will install over the center shaft of the driven gear with the cutout falling over the key on the driven gear. Make sure that rotates freely. The fourth and final seg plate will be used to support the hours tens place digit. First, I'll install the rubber band across the 2 rubber band posts into the detents, and then slide the hours tens place segment onto the seg plate. To install, first I'll rotate the hours carry cam out of the way, and then this seg plate simply drops into the 4th compartment. Make sure the segment moves freely. And again, I'll add some lubrication here to the contact points, as well as under and to the sides of the segment. And finally, just like the other seg plates, a little bit behind the segment on the seg plate. Okay. I'm going to give a brief demonstration of how this hours cam works and interacts with the hours tens segment. Since this is a 12-hour clock, the hours need to display a 1 through 12. However, since we've only installed a 0 through 9 displaying cam set, this hours carry cam will allow for only a 0 through 9 to properly display a 1 through 12. So rotating this around to the 9 position as if a 9 was going to be displayed. All right, so currently you know a 9 is being displayed because 9 is the home digit. That's where the boss here on the driven gear is in perfect alignment with the limit switch spring peak. So going from a 9 to a 10, the hour carry cam, of course, will engage the hour's tens place segment, now displaying a 10. Furthermore, displaying 11, and then a 12, and then at 12, the following digit needs to be a 1. So, to achieve this, the motor will rotate forward, releasing the hour's tens place digit, and then will rotate in reverse, hence through the slot or the cutout on the carry cam, back to displaying a number 1. And that's how that is achieved with only a 0 through 9 cam assembly. So one quick note, when testing this, engaging the hour's carry cam against the hour's tens place segment, binding may occur in these cutouts because in a later step, the backplate, when installed, contains additional side supports for this linear motion of the tens place segment. So without that, there could be potential binding. So don't be alarmed if this thing binds as you test it in this position without the backplate. All right, moving on to the backplates. There are 2 types of backplates, 2 for the single minute digits and 1 for the hour digit. The backplate is intended to enclose all mechanical components while supporting all electronic hardware. In the following steps, I will install all electrical components with bolts and nuts. However, I have used hot glue during prototyping, but I don't recommend it for long-term use, and especially not for the stepper motor. All right, time to install these components onto the backplates, and then I'll go into details about each one and its installation. All right, starting with one of the minute single-digit backplates, focusing first on the limit switch. In total, there will be 3 limit switches, 1 for each digit, for homing purposes. For each limit switch, I soldered a pair of male-to-male DuPont wires to the normally open contacts. No additional resistor needed since I'm using the internal Arduino pull-up resistor. When installing the limit switch, make sure it matches this orientation and that it falls fully into the 2 L-shaped guides. The limit switch is secured to the backplate using M2 by 12 bolts and nuts. And then lastly, feed the wires through the cutout here. A total of 3 stepper motors will be installed on each backplate using M3 by 10 bolts and nuts. In addition to the stepper motors, a stepper driver will also be installed on each of the backplates using 2 M3 by 10 bolts and nuts as shown. Similar to this single backplate digit, the other single backplate digit has one additional component, and that is the real-time clock module and bracket. So this installs to the back side of the backplate, sharing the bolts and nuts with the limit switch. The RTC installs to the bracket using 2 M2 by 8 millimeters bolts and nuts, and the orientation should follow as shown with the curve cut on the bracket lining up with the circular side of the battery housing. The third and final backplate for the hours digit contains all the same components, minus the RTC, from the other 2 backplates, but now with one additional component, and that is the Arduino Uno. The Uno is installed on the backplate using 2 M3 by 10 millimeter bolts and nuts at opposite corners. Make sure the USB connector as well as the barrel connector point down towards the stepper motor so that it lines up with the cutout inside the body for connection. A total of 3 drive gears will install on each stepper motor with the toothed end away from the backplate. It should have a snug fit with little to no play. Now to install the backplate assemblies into the clock body. Drop each backplate into place. You may need to rotate the D1 camshaft so that the 2 teeth of the driven and the drive gear mesh. There is a viewing window that you can see to make sure they've fallen into place. I recommend installing the backplate that has the RTC module into the center digit spot. All right, I'll now place the standoff style screws at the outer corners within each half of the clock. And then the remaining standard countersunk screws will take the remaining spots. After all screws are loosely placed, I will tighten them up in an opposite corner pattern. The standoff styled screws contain an internal flat blade screwdriver cutout. In this case, I'm using a 3.5mm flathead screwdriver. All right, now it's time to make all the electrical connections. All connections will be following this wiring schedule. So, first column showing all the non-Arduino components and their associated pin connections, and then the third column being the connection pin on the Arduino. I'll first connect the 9-volt DC circuit to the stepper drivers and Arduino using a custom splitter containing 2 barrel connectors, one male, one female, and 3 pigtails, one for each of the positive and 0-volt connections to the stepper drivers. Okay, moving on to the RTC connection. I'm going to use the SDA and SCL pins that are closer that I'm pointing to right here, as opposed to the A4 and A5 SDA SCL pins over here in the opposite corner. And similarly, since there is a total of 4 ground connections needed to the Arduino, with the first 3 on these rails being taken up by the limit switches to be installed next, I'm actually going to use the ground pin over here on the ICSP header. The ones place switch will connect to pin 2 in ground, the tens place pin 3 in ground, and finally the hours will connect to pin 4 in ground. And finally, based on the wiring schedule, time to connect the stepper motor drivers to the Arduino. So stepper module number 1 will be pins 6, 7, 8, 9. Stepper module 2, 14, 15, 16, 17, or also known as A0, A1, A2, A3. And then stepper module 3 will be pins 10, 11, 12, 13. And final step, connect these stepper motors to the drivers. Accessing the previously installed mechanical components is straightforward and does not require any removal of these electronic components or wires. Let me demonstrate. So I'll first remove the screws from the minutes side of the clock. So if I was only to access the minute side of the clock, I would remove the screws as I did, and then you can simply lift up, keeping all the wires together, and then just move that out of the way. You can set that off to the side. Now you have access to the minutes. Likewise, You could do the same thing with the hour side and fold that one over, or ultimately, if you need full access, just remove all the screws and lift this up entirely as one unit and set it off to the side. All right, I'll now connect the Arduino to the laptop via the USB-B to A cable. In the script, I will uncomment the time set function, enter the current time, and flash the script. And now I will recomment the time set function, and then flash to the Arduino one final time. All right. Just like the body, there are two matching halves for the back covers and a set of 8 countersunk screws to hold that on. The larger cover goes over the larger half of the body. And the smaller goes over the smaller half. One thing to note, the teardrop shapes here seen on the back covers, these are for wall hanging application. The wires potentially could be in the way, so just be mindful of that and push those out of the way accordingly before hanging that. All right, I'll now flip it over and then plug in the 9-volt DC power supply. At initial power up, each digit will first home itself, followed by cycling to the correct display to meet the current time. Just a note here, the minutes ones place and the hours ones place, each of these digits, the home display is the number 9, whereas for the minutes tens place, the home display is the number 5. Now to see in action a change from 12:59 to 1 o'clock using the hours tens place cam. Awesome, seems like it works. Side note, if any of the segments are partially showing or not fully hidden, an adjustment may need to be made to the placement of the limit switches, as the home position is not exactly as it is for me in this example.